Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, episode 9 of 17. Your code is now smart enough to know exactly when to use your laptop memory and when to fire up a cloud cluster. This is the core concept behind pandas on Snowflake, hybrid execution. When you use standard pandas, every operation runs in your local machine memory. If you load a massive dataset, your process crashes. The Snowpark Pandas API solves this by mapping your pandas commands to SQL and executing them in the Snowflake warehouse. But not every pandas function has a direct SQL equivalent. Certain operations, like plotting or applying specific custom Python functions, require the actual local pandas library to execute. The challenge is seamlessly shifting between the cloud engine and your local environment without dragging gigabytes of raw data across the network. Hybrid execution handles this transition dynamically. It is an execution model built entirely around optimizing for the lowest possible data transfer cost. When you run a script using the Snowpark Pandas API, the engine acts as an intelligent router. Its default behavior is to keep the data in the cloud. It translates your code to SQL queries and executes them using Snowflake Compute. Let us walk through a practical scenario. You start with a table containing 10 million rows. You write a line of code to filter out invalid records, and then you group the data to calculate an average. Up to this point, the engine translates your filter and aggregation commands directly to SQL. The Snowflake warehouse performs the heavy lifting. Your local machine does not download a single row of that massive dataset. The aggregation reduces those 10 million rows down to a summary table of exactly 7 rows. For your next step, you write a command to plot those 7 rows into a chart. Plotting is inherently a local operation. The Snowflake database engine cannot draw a chart for you. Here's the key insight. The engine recognizes that the plotting command requires a transition to the local pandas backend. Because the engine processes your operations intelligently, it looks at the state of your data right before the local operation is requested. It knows the preceding aggregation results in only 7 rows. So instead of moving the original 10 million rows to your laptop to process the aggregation locally, it lets Snowflake finish the math in the cloud. Then it triggers a download of just those final 7 rows into your local memory. Once the data arrives in your local environment, standard pandas takes over. The local library executes the plot command using those 7 rows. Any subsequent operations you perform on that specific data structure will continue to run locally because the data has already crossed the network boundary. The system isolates the heavy data manipulation inside the cloud infrastructure. It defers network transfer until an operation strictly demands local execution. By the time that demand occurs, your data manipulation steps have usually reduced the dataset to a fraction of its original size. You retain the API syntax you already know, but you completely avoid the network bottleneck. The defining feature of hybrid execution is not just that it falls back to local memory, but that it strategically shrinks the payload in the cloud before making the leap. That's all for this one. Thanks for listening and keep building.